Okay, having completed the solution of the compartmental model by matrix inversion, we can also look at another way that these kinds of models can be solved. That's solutions of sets of linear simultaneous equations, and that's by iteration, which is actually a more generically applied technique. So it's one that's definitely worth knowing about. And here we go, it's set up for you. Again, there's a text box which you can follow through. This is the coefficient matrix, which you've seen before. It's on the previous tab. These are the k values, the transfer coefficients, set out as a matrix. In this green section of cells, we're going to be calculating the concentrations in each of the compartments. So to do that, we need to rewrite the equation. The equation that we have at the moment is the transfer coefficient times the concentration in compartment 1 plus the transfer coefficient times the concentration in compartment 2, transfer coefficient times concentration in compartment 3, transfer coefficient times concentration in compartment 4, plus the transfer coefficient times the concentration in compartment 5 equals -1 in the case of the first equation. The other equations it's equal to 0, but in this case equal to -1. What we need to do is to get x1, which is the concentration in compartment x1, on its own. So to do that, we need to subtract all these other terms and then divide by k1. So that's what's gone on here. x1 is equal to minus transfer coefficient by concentration, the sum of each of those. So they've all become negative. And the -1 has changed sides, so that's become positive. And then everything's been divided by k1. So if you look at that, then you should be able to figure that out quite straightforwardly. Similarly, you're going to have an equation for x2, for x2, and for x3, x4, and x5, and you need to write those equations in. The first one's been written in for you, and if you just look between these commas, you can see what it is, which is, as it says there, minus k2 times x2, so that's the first term there, d11 times minus L12. Okay, these are the concentrations of the other compartments which needs to refer to. Notice that it's referring to them in a separate column. Okay, but that's the equation that you've got written down here. Okay, but where the reference is made to the concentrations in these other compartments, they're made to this second group of cells. Similarly, if we click on this, we've got the same equation, however it's referring to concentrations that are going to appear here. Now there's nothing there at the moment because you haven't filled the equations in, so you need to fill the equations in similar to this one. The easiest thing to do is to copy it down and then change it. Remember, the one for x2 is not going to feature that -1 because it's 0, it's equal to 0, so there won't be anything there. You can make those changes. You go ahead and write those equations in. We'll just pop them in now. And okay, when you've written them in, effectively you're writing the equation in twice, and it's referring to the concentration in the other column. Now, to explain what's going to happen, these other terms in this formula, first term is an if, so there's an if statement which is referring to this little control section up here. There's a stop and start. if there's a 0, so I7, if I7 is 0, 0 is taken as being false. So if it's false, then it won't carry out and insert this calculation. It'll insert the second term, which is the initial guess. To start with, we've put in a 0, stop the process, and then the formula evaluates the 0. If I7 is 0, then the formula evaluates to I8, which is 2, and that formula is in all of these cells. That if statement's in all of them. So they're all evaluating to 2. If we type a 1 in, then the formula, if you read it, if I7, I7, if it's a number rather than a 0, then that'll be taken as true, and then this calculation will be done, and that value will be inserted. So that's the calculation, that's the formula you've worked out for concentration in X1, so that will be inserted. Now it hasn't happened yet, because we need to press F9, because we've turned on manual recalculation, so it doesn't happen automatically. But when we press F9, then that calculation we put in, that calculation is going to refer to these cells. So it's going to use these initial guesses in working out the concentration in the other cells. Now that's not going to be right unless your initial guess happens to be exactly the right answer. But the calculation will repeat, that's the iteration that goes on. And it will take the results effectively calculated in one column and then use that result in the other column, and then use the result from that column in this column, and those results will get passed between the columns, and that's the iteration process, because the manual recalculation and iteration are set. So instead of it regarding it as a circular reference, which is what it would normally do if automatic calculation was set, because these formulas are referring to cells that are actually being calculated, and that would be a circular reference, but actually it's letting that go ahead as a procedure. So if we actually go, you can either go to formulas and press calculate now, or you can press F9, which is quicker, and actually that's recalculated 100 times in order to come to that number. And if we press calculate now again, okay, the numbers aren't changing, so they've actually settled down, they've converged on the final answers. And I've copied in here the answers you got from your analytical solution, which was from matrix inversion, and you can see that actually you've got the same numbers. And if we and I've formatted 2 decimal places, then they're exactly the same. It's good to see a few more decimal places when the recalculation is going on, so you can see them changing. So that's the process of iteration, which is basically you start with an initial guess, and then you use the results using the initial guess and plug them back into the formulas and keep on repeating. And that's actually a process that's generally used in computer solutions when you're dealing with large numbers of equations.